Right. This is my attempt to quickly explain polar, nonpolar bonds and molecules. Right. So the first thing you should notice is that a bond is always two elements. Right. And those two elements can be the same or they could be different. You have two of the same element, like HH, OO, FF, ClCl, then it's going to be a nonpolar bond. Then HH, OO. O is a double bond, which you'll learn about later. FF, ClCl. Right. So why are those nonpolar bonds? So again, they're nonpolar because they're symmetrical. Right. One thing you have to remember is SNAP. Symmetrical molecules are nonpolar. Asymmetrical molecules are also polar. So symmetrical bonds are also nonpolar. So these are symmetrical. H on the left, H on the right. O on the left, O on the right. F on the left, F on the right. So when the bonds are the same, it's nonpolar. When you have different elements combined, like HCl, H and O, C and H, those are polar bonds for the sake of high school. Right? So if I do HCl, I have H on the left side of the bond, I have C on the right side of the bond. That's not the same. Those are polar. If I have water, water actually looks like this. So water is H2O. So the HO bond is polar. This HO bond is polar. And the entire molecule is also asymmetrical up and down, right? Bilaterally. Right, so let me do like a quick test for understanding. So if I had this molecule here, hydrofluoric acid, is that polar or nonpolar? How about HCl? How about HH? How about oxygen, O2 with the double bond? Really quick, O2 needs a double bond because it needs two electrons. H needs one electron. Fluorine, chlorine needs one electron, so I have one bond. Right? How about Cl and Cl? You may notice that you'll see a lot of these examples over and over again. Right? That's a really quick example of polar and nonpolar bond. Two different elements, polar bond. Two of the same elements, nonpolar. So really quick, this is a polar bond, and since there's only two elements, it's also a polar molecule. So the whole thing is asymmetrical. Right? This is also a polar bond, and since the whole thing only has two elements, it's also a polar molecule. What? I fed you, cat. This is a non-polar bond. Non-polar bond, because this is symmetrical. So since only two, it's non-polar molecule. Right? Oxygen needs two bonds because it needs two electrons. So, but it's the same on the left, same on the right. Non-polar bond, non-polar molecule. And then again, ClCl, Cl on the left, Cl on the right. Non-polar bond, non-polar molecule. Most students, when I just give them that in like 5 minutes, it's like, oh, it's so easy, I got it. Right? Where your minds get lost, or most people lose their mind, is when we talk about other nonpolar molecules that involve multiple different bonds. So you see I have one bond here, right? Or there's two elements here. All these. So these are pretty easy when you have two elements. It gets a little silly or a little crazy when you have more than two. Let's move to the next example. Let's move on. All right. So now some of these have more than two. So a non-polar covalent molecule, and again, I want to really emphasize SNAP, right? So the symmetrical molecules will always be nonpolar. Right, nonpolar molecule or nonpolar, SNAP, nonpolar molecules, and asymmetrical molecules are always polar, right? So let's look at these examples here. All right, I got H2O2. Why can't I even draw this? H2O2 deals already. Let's try CH4. So you will have to know that carbon-based molecules, so carbon C, with 4 elements around it will be symmetrical, right? Why? Because the top, bottom, left, and right have the same elements, right? Top I have H, the bottom I have H, left and right I have H. This is symmetrical, right? So it's non-polar, symmetrical, and nonpolar. Snap. CCl4 4 follows the same pattern. C with 4 chlorines up and down. That is symmetrical. Right? Chlorine up, chlorine left, chlorine right, chlorine down. Symmetrical. 4. All right. So that is symmetrical and nonpolar. Why is CS4 symmetrical? Because you have S on the top, S on the bottom, S on the left, S on the right. Why is CO2 nonpolar? That doesn't make any sense. CO2 looks like this. You do need to memorize this structure, right? Sorry that I can't draw a circle. So I have O on the left, I have O on the right, I have nothing on top, I have nothing on the bottom. That is symmetrical, okay? So now the asymmetrical molecules are polar. So something like NH3 or C6H12O6, you'll never see an example like that, but so you will see NH3, right? NH3 looks like this. So it's symmetrical left side and the right side, but up and down it is not. So that's why it is a polar molecule, right? And water looks like this. So left and right's symmetrical, but up and down it's not. So that's why it's polar. All right, so let's test out some examples here. So let's try, let's do actually ethane, right? So it's 2 C's and 6 H's, H pair, hydrogen pair. All right. So now, is this molecule symmetrical? Does the left side have the same amount of atoms as the right side? All right, just test yourself. And if it's symmetrical, is it polar or non-polar molecule? Right. So if you said this was a symmetrical and non-polar molecule, great job. Yes, the left side and right side are the same. So it's symmetrical and non-polar molecule. Now, if I asked about what type of bonds does it have, right? You have to look at 2 elements. So let's look at 2 elements. Let's look at C and H. Are those the same? Is capital C the same as capital H? No. That's why this particular bond is polar, right? How about the bond between C and C, right? So C and C has the same element on the left side and right side. Remember, bond is 2 elements. So this is a symmetrical bond, right? And a symmetrical molecule. So one thing you need to hammer into your head is that some molecules can have symmetrical and asymmetrical bonds. As long as those elements are distributed equally, it will be a symmetrical molecule. So let's try another example. So let's try this. Is this a symmetrical or asymmetrical molecule? All right, how about, let's try, no, I can't even do that one. Let's try, well, let's just do it again. All right, so how about this, just to refresh? You'll see the same examples 1,000 times. They'll always use carbon dioxide. They'll always use carbon with an element that has 4 around it, right? So it could be CF4, it could be CCl4, it could be CBr4. You could also technically have CI4, but they won't do that because CI looks like Cl, so they won't do that. But you should recognize that carbon with 4 elements around it will always be non-polar because the elements are equally distributed, or the atoms are equally distributed up, down, left, and right. So there'll be no poles, right? I want to give a few more examples to check people's understanding. So let's say I just made up, let's just try something like, something non-polar. We could do, most of them are carbon-based. You really don't have more examples than this, but let's try and mix them up. I mean, I literally just said this. So CBr4, what's that? Right? Is it polar or non-polar? How about HF? How about HCl? Remember, if it's polar and non-polar, these are only dealing with non-metals. And most of the time, when you have a non-metal, carbon and hydrogen will be involved. So almost all your examples will have hydrogen or carbon. So of these, which ones are polar and which ones are non-polar molecules? Let me see what else we got here. And I mean, I hope you can see there's not many examples of polarity, ones of polarity. Could do, I mean, this was another example, H2S, you could say. Right. So which one is a non-polar molecule, right? So of these six, which is a non-polar. So I know this is non-polar because 4 bromines. I know that this is non-polar because there's 4 chlorines around. And the rest are polar. So most molecules will be polar. So HCl is polar because H on the left, C on the right. HF is polar because H on the left, F on the right. Water is polar because even though it's symmetrical left and right, it's not symmetrical up and down. So that's why water is always polar. And H2S also looks like water, right? I think that helps. Let me know if it doesn't. But I think adhering multiple times is good, right? Thank you for watching.